Okay, so how to name various types of acids. First of all, we're going to name the halogen acids. And remember, the halogens are group 17: fluorine, chlorine, bromine, iodine, so on and so forth. Okay. Now, you already know one of these, HCl. You've heard this name before, hydrochloric acid. So here's what you do when you have a halogen acid. They're the only ones with hydro on the front. Notice the ending is ic and then acid. Okay, HI. Hydro again, ic, and then acid. Okay. HBr is hydrobromic acid. HF is hydrofluoric acid, so on and so forth. Okay, so you might remember last unit when we were telling you guys how to name polyatomic ions. So if you start here, okay, this is 3 oxygens attached, 4, 2, and 1. Okay, so this one right here is a chlorate ion. Remember, if we have one more oxygen, it's still 8, but it's perate. Okay, one less is ite, and then one less than that is still ite, but it's hypoite. Okay, hypo means less than. And so what we do is we follow the same pattern. So if you notice this, that's a negative, okay, negative charge. What it can do is one hydrogen can attach to it. Therefore, now it's an acid. Okay, so let's look at each of these. There is a pattern to naming these. What happens instead of the 8 ending, the 8 ending of the polyatomic ion when you have an acid becomes an ic ending. So same thing here. 8 ending becomes ic, and you still keep the per in there. Okay, if you have one less, instead of it being ite, it's us. And if you have one less than that, instead of it again being ite, it's still us, and we still have the hypo in terms. Okay, so basically that's the pattern in order to name these. Okay, so let's go ahead and name a few of these. First of all, these are all halogen acids. So HF is going to be hydrofluoric acid. Hydrofluoric. Next one, HCl is going to be hydrochloric acid. Next one, hydrobromic acid. And the next one, HI, is hydroiodic acid. Okay, so next, this is where we need to identify what is the polyatomic ion that's attached. PO4, if you look up PO4 on your polyatomic ion chart, okay, H3PO4 is the acid that's made from the PO4 3 negative. That is phosphate. Now remember, when you're naming an acid, so that would an acid be with the 3 hydrogens attached. The 8 becomes ic. But now we've got phosphoric acid. Okay, next one. If you notice, we have NO2, NO3. You know, what we want to find out is which is the polyatomic ion that it's attached to. So if we look on our polyatomic ion chart, NO2 is nitrite. Remember, naming acids, ite becomes us. So that would be nitrous acid. Next one, that's an acid made from the nitrate ion. So that would be nitric acid. Next one, we have 2 ions. That is the sulfite ion. That's the sulfate ion. So the first one is going to be sulfurous acid. The second one is going to be sulfuric acid. Next one, CHCO3. If you look on your polyatomic ion chart, that's acetate. So the 8 becomes ic. So it's acetic acid. It's actually vinegar. That's an important one you need to know. And remember, I mentioned CH3CO, acetic acid. It's actually a monoprotic acid. This hydrogen's the only one that can leave. The other ones are covalently bonded and they're too strong. Okay, next we need to identify what these polyatomic ions are. And this one is hypochlorite hypochlorite ion. And so that one is going to be hypochlorous acid. I'll write it. Okay, next one is ClO2, and that is simply the chlorite ion. So that's going to be chlorous acid. Next one, that's the chlorate ion, so that's going to be chloric acid. And then the one after that is going to be perchloric acid. The last one, CO3, is carbonate, so that's going to be carbonic acid. Okay, so that will conclude naming various types of acids.